Okay, in this video we're going to introduce matrix multiplication and multiplying a matrix times a vector. So matrix multiplication, unlike addition and subtraction and scalar multiplication for matrices that we talked about in the previous section, matrix multiplication doesn't work the way you might think. For instance, if we have matrix A is a 2 by 2 matrix here, and matrix B is a 2 by 2 matrix, based on how we looked at adding matrices and subtracting matrices and even multiplying a matrix by a scalar, you might be tempted to think that you just have to multiply the corresponding entries or the corresponding elements, like 3 times negative 1 to get negative 3, negative 2 times 4 to get negative 8, etc. However, the way we define matrix multiplication, we don't just multiply the corresponding elements. So A times B is not going to give us what the product of the corresponding elements are. For instance, 1 times 5 in the second row, first column, gives us 5, but this is not the correct answer. In fact, what matrix multiplication does in terms of visualization and seeing this actually happen is every time you multiply by a matrix, and we're going to use a 2 by 2 matrix to start, you're creating new basis vectors, I hat and j hat. So if you think of your coordinate plane and a grid in graph paper, you have the square grid that you can use to plot points. Well, if you multiply by a matrix, what it does is it's going to transform that grid into something else. Maybe it'll rotate it, maybe it might flip it and reflect it across a line, stretch it out, compress it, a whole bunch of different transformations we can do. Matrix multiplication also has quite an extensive list of applications. There are entire courses dedicated to working with matrices and looking at what they can do. But for our purposes, we're going to just touch upon how to multiply matrices, not in the traditional way that most Algebra 2 courses would cover. So we're actually going to see it as a transformation. So before we begin, we have to check our dimensions, because if we even want to bother multiplying a matrix by a vector or by another matrix, then we got to make sure that the number of columns in the first matrix equals the number of rows in the second. That's going to be very important. So if we have an m by n matrix, we can multiply it by an n by r matrix. Remember, the first value represents the number of rows. This might be like a 2 by 3. And then the second number here represents the number of columns. So if this is 3 columns, this next matrix would have to have 3 rows. And our result is going to be a matrix that has this number of rows and this number of columns, or an m by r matrix. But before we multiply a matrix by a vector, a matrix or a vector by a vector or another matrix, the number of columns in that first matrix must equal the number of rows in the second. All right, so let's look at the basis vector I hat that we talked about in the last section, which is 1, 0. And we're going to see what happens to I hat when we multiply by the matrix 2, 0, 0, 2. And so what we're going to do is we're actually going to take this first element in I hat, this 1. So we're going to take this 1. Oops, meant to do the highlighter. Make sure I select the highlighter. We're going to take this 1. There you go, highlighter selected. And we're going to multiply it by this first column. Then we're going to take this 0 and multiply it by the second column. So this is how we're going to define matrix multiplication. Essentially, it'll boil down to this basic case here where we have a matrix times a vector. So let's do that. Let's take, make sure I select the right pen here. We're going to take 1 times this column. So our first element 1 times this column. Whoop. And I thought I changed the ink color. But here we have 1 times this first column. There we go. And then we're going to add to that this 0 times this second column. So we have this 0 times this second column. And this is a little bit different than the way a lot of teachers, especially in Algebra 2, will present matrix multiplication. The good news is the way I'm presenting isn't going to give you a different answer, but it will kind of give you an idea of visually what happens when you multiply matrices together. So we have scalar multiplication here. We looked at that in the last section. We have 1 times this vector is just that vector, 2, 0. Here we have 0 times this vector, so what we end up with is a vector of zeros, and sometimes called, this is called the null vector, N-U-L-L, the null vector. A null vector is just a vector that has zeros, but you don't have to worry about that for this course, but if you take a course in linear algebra in college, you'll hear this term quite a bit. So adding vectors together, we know we add the corresponding elements. So 2 plus 0 for our first row gives us 2, and 0 plus 0 gives us 0. So actually should have checked before that the number of rows, or the number of columns rather, in this first matrix equals the number of rows in the second, and it did because we were able to highlight this row and this column, this row and this column. We didn't have any additional rows in this matrix. We didn't have any additional columns in this one, so that's kind of the reason why we have that condition. So we get to 0. So let's take a look at that. So if we look at I hat as 1, 0, so we'll graph I hat. There's our original I hat. Now let's look at this new I hat vector 2, 0. So that's going to go out to 2, 0. So this is our new I hat. We'll call this one in blue. We'll call that I hat prime. Oop, didn't mean to, forgot to undo the vector. We'll call this blue one I hat prime. And we'll call the original one, that our original definition of I hat, just I hat. So if we notice, what happened was it took our original vector and scaled it by a factor of 2. So it multiplied it by 2. So this would be like zooming in, and now our segments of our image, if we had an image we were zooming in on, the segments are twice as long, which is zooming in, I believe, by a factor of 100%. And that's what happens when you multiply I hat by this matrix. So notice also that, we'll get into this a little bit later, if we factor a 2 out of all these terms, we get 2 times our identity matrix that we talked about in the last section. So, but that about does it for this video. Thank you for watching. I will see you later.